So what are you guys?
We are the Swartwood family.
So are you guys real Swartwood MCAT students?
Hell yeah!
Okay, so let's start with friction then. I kind of have a good idea of where we are. Especially if they do more difficult problems, this thing actually matters. Here it's just a number. You can just compute it. Do you guys remember what this represents? Why they put that stupid less than or equal to? So that this guy doesn't fall. Okay? But there are two things. One is I could push just hard enough so it doesn't fall, or I could push a little bit more. What would happen if I push more than what I need? If I push a little bit more, he should start going which way? Up. But then friction's going to do what? Help me or hurt me? Friction's always going to hurt me. So then it might be harder to push him up because now friction's working against me. Do you guys agree? So I have to tell you this. I want the minimum force. I want you to give me the minimum push you need such that this guy doesn't fall. Okay? Then help me out. Tell me where the forces are. Who's always pulling you down? Gravity. So gravity's going to pull you down. No way around that. Okay. Then I guess there's a normal force, right? You're pushing this guy into the wall, so what's the normal force going to do? It's going to push out. Normal force can only be perpendicular to the surface, so it's got to push back out this way. That's not a big deal. Okay? I need to put friction in there. Do you guys, especially for people who've seen this with me before, do you remember how to predict which way the friction force is? That's why it's tricky. It'll flip on you. Always go to an extreme. So the extreme case is, I just barely want to hold him up. So imagine my force is almost nothing. If my force were almost nothing, which way would this guy go, up or down? If I were just barely touching him, it looks like he would go down. Do you guys agree? And if he started to move down, which way your friction point? Up. So that's the way I'll take friction. Force of friction. In fact, let me label them like this, force of friction. Okay. You have to decide the sign. So it's not like you put in a negative or positive normal. You can't do that because these directions are perpendicular. Okay, so let's go ahead and finish this then. I think we're almost done. This is a definite number. The problem is I've got two stupid variables. I've got this guy and I've got that guy. That's the guy I'm solving for, so I don't think we'll make progress with him. But at least I can go for what? The normal force. And when we do rotational stuff, we have the up and down, and we have what? The left and right, side to side. But you also know, if this guy's not moving, what are the sum of forces in the left and right direction?